Okay, so let's look at exercise 1, question number 11. So the question here says that a particle is initially accelerating towards east with a velocity of 5 meters per second, and over an interval of 10 seconds, the velocity changes to 5 meters per second northwards. So we have to find the average acceleration. So this question is about the application of vectors in kinematics. As per the definition, that average acceleration is equal to, we define average acceleration as average rate of change of velocity with respect to time. So it's delta v by delta t, or you can say it is change in velocity, final velocity minus initial velocity divided by the interval of time, like that. So here what is happening, initially the body is moving towards, or the particle is moving towards the east with a velocity of 5 meters per second magnitude. So you can do this in two ways again. You can use geometry, or you can use component algebra. So going by the geometry method, let us say this is the direction towards the east. So the initial velocity is this vector pointing eastwards, and the magnitude of that velocity is 5 meters per second. This is pointing towards east. Now what is happening after 10 seconds, the final velocity is changing to something that is moving northwards. So the direction of, so obviously the particle was going like this, and then it turns and goes northwards like this. Okay. So the velocity is changing, the final velocity is changing to 5 meters per second, but pointing towards north, like this, in an interval of 10 seconds. Okay. So this direction here is pointing towards west, and this is pointing towards south, like this. So this is our coordinate frame where we have considered north, south, east, just like this. Okay. Now the change in velocity in this particular case will become what? It will become the final velocity minus initial velocity. So that in this vector parallelogram, it's now actually a vector square. It's becoming like this because this angle is 90 and this side is equal to this side. So this will be your delta v. Your change in velocity will be final minus initial. So it will be the arrow pointing from the head of initial to the head of final. So it will become 5 root 2 meters per second in magnitude. And you can see its direction is towards northwest, because this direction, this angle is exactly 45 degrees, same as this angle. So in this you can see that delta v, or change in velocity, is nothing but 5 root 2 meters per second towards northwest, 45 degrees north of west, like that. So because it's 45 degrees, we can just say northwest is perfectly bisecting that angle. So that becomes a change in velocity. So once you understood the change in velocity, you have to just divide it by the time interval. The time interval is given to us as 10 seconds. So the average acceleration here for us is becoming change in velocity upon change in time. So it becomes 5 root 2 meters per second northwest divided by 10 seconds. So the average acceleration is having a magnitude of 1 by root 2 meters per second square, and it's towards northwest. Yeah, so alternately, if we want to use component algebra, we can do this also. component algebra, we will define our coordinate frame with geographical directions. So, for example, if we define our x-axis to be along east, so a negative x-axis is towards west, our north is pointing along y-axis, so negative y-axis is pointing towards south. So in that case, in the same problem, the initial velocity, which is 5 meters per second eastwards, will be given in component form as 5 I cap, because I cap is pointing towards east. And likewise, our final velocity, which was 5 meters per second north, now northwards is the direction that is pointing towards j cap. So our final velocity will become 5 j cap. So our change in velocity, so our average acceleration, which is change in velocity upon change in time, will become 5 j cap minus 5 I cap divided by 10 seconds in meters per second. So the average acceleration as a vector in component form will be minus 1 by 2 I cap plus j cap in meters per second square. So now we'll have to interpret this acceleration in terms of magnitude and direction. So we'll have to understand that this particular vector has a magnitude of square root of, so that is and direction. For direction, you will have to understand it in context of our reference frame. So in context of our reference frame, this acceleration vector, you can see it's like this. It has a negative x component and a negative y component and a positive y component, which are both equal in magnitude. This has minus half plus half. So obviously this angle is 45 degrees. So you can see that it is pointing northwest. That is becoming the direction over here. Right, so this is clear too. So moving on to the 12th question. It's a very interesting question geometrically. It says that 5 forces of equal magnitude act such that they are all lying in one plane. They are of 10 magnitudes each, and the angle between any two adjacent forces are equal. So the resultant of these forces will be how much? So let me just illustrate the language of the question first. It says that you have 5 forces of magnitude 10 newtons each. Okay. That are in the same plane. That means they are coplanar. Okay. Such that the angle between any two consecutive forces are the same. Then you have to find the resultant. What is the resultant of these forces? So let us understand this by first figuring out geometrically what they mean by this. So suppose the forces are lying. So let's interpret the language of the question like this, that suppose we have forces F1, F2, F3, F4 and F5, and they are coplanar, and their magnitudes are 10 newtons each. So suppose the plane in which they are lying is what we have drawn as our xy plane. So let us assume, or let us take our xy plane as the coplanar, the plane in which these are lying. This is our xy plane. And further, let us assume that we have taken our x-axis to be along one of the forces, which is F1. So the force F1 in my diagram is along the x-axis, and it's of magnitude 10 newtons. This F1. Now in comparison to F1, F2 is, let's say, somewhere over here. Then F3 is, let's say, somewhere over here. Then F4 will be somewhere over here. Let's say. Finally, F5 will be somewhere over here. So these forces would have to be, along angles or along directions such that the angle between any two consecutive forces is the same. That's the trick over here to understand. Okay. That these forces all are of magnitude 10 newtons, but such that this angle theta between F1 and F2 is exactly the same as this next angle theta between F2 and F3. It is exactly the same as the angle between the next two. It's exactly the same as the angle between the next two. And these two are also having the same. And the forces are all 10 newtons in magnitude. Yeah, so this is the meaning of the earlier statement about the geometry of the forces. They are all of equal magnitude 10 newtons each, but they are also spread out like this. So you can see that from the diagram, you can see that 5 theta would be equal to 360 degrees. It means each of those angles is 72 degrees. And magnitude of the forces is equal to 10 newtons each. Okay. Of course, you might say that, okay, we've drawn the vectors like this, so yes, you might say that we've drawn the vectors like this, so let's write F1, F2, F3, etc. in component form. You can do that, but one of the difficulties in that is then 72 is not, one of those known kind of angles where we can immediately find cos theta and sin theta. We'll have to look it up in a table, etc. But there is something else about these vectors. They are symmetrical. So since they are symmetrical in this manner, let us try and make use of geometry. So if you want to add them geometrically, let's see what happens then. So to find the resultant of these vectors geometrically, we have to draw them head to tail. So to find the resultant, draw them head to tail. Okay. So if we were to pick up those vectors drawn earlier and draw them head to tail. So let's start with the vector F1. So that was pointing along our positive x direction of 10 newtons magnitude. Now we'd have to draw F2 at 72 degrees. So that would be something like this, let's say, roughly speaking. and of the same magnitude, 10 newtons. I have to draw F2 like this, where this angle would be theta equal to 72 degrees. Okay. Then we draw the next one, be something like this. Then the next one, which would be something like this. And we can be pretty sure that the last one, the fifth one, will give us this. Because if we now start comparing our figure with the geometry of a regular pentagon, that is a polygon of 5 sides with equal sides, we'll see that it matches exactly. So this is based on the geometry of regular polygons, which I'll reiterate separately also, but let's understand this. So because each of these angles are 72, it so happens that it's like, forget for a moment that these are forces. Think of them as displacements. So if you make a displacement of 10 kilometers, then turn 72 degrees, anti-clockwise, make another 10 meters, then again turn 72 degrees and repeat this 5 times. So it turns out that you will be back to where you started. So that is why the resultant of these vectors will basically become 0. Because drawn head to tail, they form a closed figure. In this case, that closed figure is the regular pentagon, okay, of side length 10 newtons. So on drawing them head to tail, what we observe on doing this, what we observe is that the resultant becomes 0 because the forces or the force vectors form the 5 sides of a regular pentagon. Like this. That's why the answer should be resultant is equal to 0. Okay, so let me explain a little bit about the geometry of any n-sided regular polygon, and from that it will be a little bit clearer or a little bit easier to understand how we were able to arrive at this conclusion straight away that the sum of these 5 vectors which we have drawn from the origin of our xy plane like this, how we can be so sure that when we join them head to tail, it has to give us this regular polygon. So let's understand. Geometry of an n-sided regular polygon. Then we will convert it to vector algebra. So, for example, n equal to 3, the polygon in question becomes a triangle. So, if the polygon is regular, it will become an equilateral triangle. So, the geometry of an equilateral triangle, you know, is that because these sides are equal, you also see that at the centroid, each of the sides will subtend an equal amount of angle. And if you draw the sides as vectors, you'll also realize that the angle between any 2 consecutive vectors will be the same. this exterior angle will be the same as this exterior angle. Will be the same as this exterior angle, and that theta will be equal to 360 divided by 3 or 120 degrees. So when you convert this to the relation of vectors, what it means is that if I have three vectors which are coplanar, which are equal in magnitude, okay, and make equal angles with respect to each other. If I have three vectors, say A, B, and C, whose magnitudes are equal, and they make equal angles, so their resultant will be 0. Why? Because when you draw them head to tail, they will become this triangle. So when you draw these vectors head to tail, you will get that particular equilateral triangle. Let's say the side length is some small a. So this is the geometry of the three-sided regular polygon converting to vector algebra, which tells us that we have three forces or three displacements or three vectors of equal magnitude which are coplanar, and such that the angle between consecutive ones is same. So that angle is 360 divided by 3, 120. When you draw them head to tail, they will form that equilateral triangle, and the resultant will be 0. Now likewise, if we explore the geometry of the 4-sided or 5-sided or 6-sided, okay, so you'll understand this happens. So for example, for n equal to 4, it's very easy to guess. The polygon becomes a square. I mean, the polygon becomes a quadrilateral. So if we're talking about a regular polygon, that regular quadrilateral becomes a square. So it's like this. If you have 4 vectors which are coplanar and of same magnitude and making identical angles with respect to each other, any two consecutive vectors at the same angle, naturally they'll all be at 90 degrees to each other. So the vectors will be like this. So these were 4 forces at theta equal to 90 each of same magnitude. Okay. Drawn head to tail, see, they would just form a closed square like this. Okay. So the resultant becomes 0. Okay. These 4 sides would be equal. Like that, the 5-sided case we've just discussed, the regular pentagon. Similarly, if we had, for example, 6 forces which were of equal magnitude and each one making the same angle, with respect to the next consecutive one. So we would have a shape that would look something like this. Suppose we're having this. These are all equal in magnitude. So we have 6 forces, suppose we had that case, which are of equal magnitude, and they are coplanar such that the angle between F1 and F2 is the same as the angle between F2 and F3, is the same as the angle between F3 and F4. So like this, all 6 angles are same. You would have seen that theta would have been equal to 360 degrees divided by 6 or 60 degrees each. Okay. Now you'll see that that corresponds exactly to the geometry of the regular hexagon. Because the regular hexagon exactly consists of these 6 vectors. You see that these angles are all theta equal to 360 each. I mean 60 each. Now another point to notice about any regular polygon is that whatever the exterior angle between two consecutive sides, that itself becomes the interior opposite angle. I mean, that becomes the angle subtended by any two of the sides, or any side at the centroid. Look at the centroid of this regular hexagon. These angles are also 60 degrees each. In this case, it's very easy because they form an equilateral triangle like this. But even if you go to the case of the square which we saw earlier, we can see that each of these angles subtended at the centroid are 90 and they are equal to this angle 90, this angle 90, angle 90. Similarly, if we see the case of the pentagon, the regular pentagon, that was also going to give us the same case in terms of the relationship between the angles subtended by each of the sides at the centroid and the exterior angle between this. You have this case. Just imagine these are straight lines which I've drawn. So these angles will also be 72 degrees each. Which will be the same as these angles. Now see why these angles will be the same, I'll explain. Because this angle, whatever it is, suppose some alpha, is the same as this angle. And that will be the same as these two angles. It will be the same as these two angles. So you can see that therefore this angle here, this one, has to be the same as this angle. Because alpha is 180 minus 72 by 2. So now the sum of these three angles has to be the same. So this and this have to be the same. So that is something we can generalize now about an n-sided polygon, whatever the number of sides are. So let's now summarize this and generalize this result for general n-sided polygon, whatever the number of sides, 3, 4, 5, 6, 7, 8, 10, etc. Now because I don't know the total number of sides, so I will not be drawing the entire polygon, but just assuming that it's continuing like this, some kind of shape. So if it is n-sided, then each of these exterior angles will be equal to how much? It will be 360 divided by whatever that n is. Okay. And when we join each of the sides to the centroid, wherever that centroid is, depending on the number of sides and all that, the centroid, then each of these angles will also be the same. There will be that same theta as those exterior angles. And the reason for that is because of this geometry. These are alpha each. The relationship between alpha and theta is, as you can see, whether you look at the triangle or you look at this whole thing, it's a straight line. So 2 alpha plus theta has to be 180 degrees. Okay, so for example, if it's a 10-sided polygon, a regular decagon, then each of those angles will have to be 36 degrees, like that. If it's an 8-sided polygon, yes, for a circle, you can say that n is tending to infinity. So n tending to infinity means theta is tending to 0, like that. For an octagon, it will be 45 degrees each of those angles. So this particular question that we did earlier was, you can say, an application of this more general concept, which is useful both for geometry and for vector algebra whenever and if it comes up. Okay, moving on to 13th question next. So this is about kinematics. It is saying that a particle moving in the 3-dimensional space. Okay. So the particle starts from, let's say, the point E, which has coordinates 1, 0, 0 at time t equal to 0. Okay. It starts at this particular time with a constant velocity of magnitude 65 meters per second. Constant speed is 65, means the magnitude of velocity is 65 meters per second. Moving towards a point. So another point given to us B, which has coordinates 4, 4, 12. So this is the information given to us, that it's moving directly towards the point B from A, but with a constant velocity of magnitude 65 meters per second. From this information, we have to find, assuming constant velocity, so that's what we've done. We have to find the position of the particle at t equal to 2 seconds. So we have to find out that at 2 seconds, what is the position? So find its position. Okay. Let's say the position is some coordinates x, y, z at t equal to 2 seconds. So let's understand the question geometrically first, what we mean by this. Okay. So let's say in my 3-dimensional coordinate frame, so this is the point E, whose coordinates are 1, 0, 0. So it's lying on the x-axis. So the point A, the way it is given to us in the question, it should lie on the x-axis. And the point B is not lying on any axis. It's somewhere altogether different. So somewhere here, let's say, which is like interpreted in front of you. So it has all three coordinates, 4, 4, 12. Try to imagine this in 3D. So what is happening is the particle is starting from the point A, but moving along this line now. It's moving along this line EB. Okay. And therefore its velocity from where it starts will be a vector along that line. Okay. So this is where it is at t equal to 0. Now at t equal to 2 seconds, we don't know where it is. Maybe it has reached B, maybe it has gone past B also, we don't know. So let's just assume that it's reached somewhere here, which is some general point x, y, z at t equal to 2 seconds. So we have to find the coordinates of this point. We have to find x, y, z. So this is, roughly speaking, what we have to do. And we know in the question that the magnitude of the velocity is 65 meters per second. This is the information that we know. So you can see the diagram looks a little bit complicated because we've drawn it in 3D. But we can simplify it somewhat if we forget about the axis and just draw the line AB. So just now imagine you're watching this from above or somewhere else. So this is that arbitrary point E. जहाँ से वो start किया है, which is 1, 0, 0. And just forget about the axis over here. Just imagine the point B. It's some point like this in relation to it. You're viewing the whole diagram from some other angle and you're just seeing the line AB. Okay. So this is the particular line along which the body is supposed to now move. The body is supposed to start from the point E and supposed to direct its motion directly aimed at the point B like that. That's how it's supposed to move. It's moving like this. But that's the direction of its motion. You can understand that. So its velocity vector, because it's a constant velocity, so displacement should be velocity into time like that. So its velocity vector should be a vector which is directly aimed from the point A to the point B. So from that I can understand that the direction of the velocity vector will be this. But its magnitude is 65 meters per second. So now we'll make use of something interesting that we notice here, that the velocity vector is directed along the line AB. The velocity vector is pointing along AB. So therefore we can say that the velocity vector has a unit vector. It is equal to 65 meters per second into some unit vector where n cap is the unit vector along the velocity vector. Now this n cap, this will be along AB. Okay. So in other words, we can also say that n cap is the unit vector of the vector joining A and B as a displacement. Okay. So what is the vector joining A and B as a displacement? You can see that if you go from A to B, it's like a displacement from A to B. That vector AB is what we are going from x coordinate 1 to x coordinate 4. So it's 3 I cap. Then from 0 to 4 along the y axis, so 4 j cap. And then 0 to 12 along the z axis, so 12 j cap. So this is a vector joining the points A and B. So ये जो vector है AB, it should have the same direction as the vector B. You can notice here that because the vector AB and the vector B are in same direction, So they will have a unit vector which is seen. So that is a point over here. So this is nothing but 3i cap plus 4j cap plus 12k cap, which is the vector EB divided by its own mod. So divided by the magnitude of itself, which is magnitude of 3i plus 4j plus 12. So this becomes nothing but 3i cap plus 4j cap plus 12k cap divided by square root of 9 plus 16 plus 144. So you know that so 9 plus 16 is 25 plus 144. That gives you 169. This is nothing but 13 square. So with that knowledge, we know that this will become 3i cap plus 4j cap plus 12k cap divided by 13. Okay. So this is the unit vector. This is the unit vector along EV, and therefore along our velocity vector, because the velocity is along that line AB. So now just going back to understanding what we have to do, we have to find the velocity as a vector so that we can next find the point in between, which is at 2 seconds, which is x, y, z. So for that we need to find the displacement. So to find the displacement in 2 seconds, first of all we need to find the velocity vector. Then we can multiply the velocity vector with 2 second time, that will give us the displacement. So the first thing we needed to do in this question was that we need to solve for the velocity vector. So how we are solving for the velocity vector? We already given its magnitude is 65. We just need to give it direction. So direction ka matlab in vector algebra terms, we need to find the unit vector. The unit vector is nothing but the unit vector along the line EB. So that is what we've done over here. So the line EB treated as a displacement from A to B is this vector. So divide this vector by its own magnitude and we are getting the unit vector which is along AB. So that is nothing but the unit vector for the velocity. So the velocity now we can express as we have shown above. We can express the velocity vector as its magnitude multiplied by unit vector. So therefore the velocity vector is its magnitude divided by some into some unit vector. So the magnitude is 65 meters per second. And just now we saw that that unit vector was 3i cap plus 4j cap plus 12k cap divided by 13. This was the unit vector. So you can see that the velocity vector will become, this will go 5 times here. So it will become 15i cap plus 20j cap plus 60k cap in meters per second. This is now giving me the velocity vector. So now from this we can see that from t equal to 0 to t equal to 2 seconds, the displacement will become velocity multiplied by time. So it will be nothing but 15i cap plus 20j cap plus 60k cap in meters per second multiplied by 2 in seconds. So the displacement will become 30i cap plus 40j cap plus 120k cap. This is the displacement in 2 seconds. The displacement from 0 to 2 seconds. Okay. Now let us find that point P. So at t equal to 0, it was at the point E, which was 1, 0, 0. And at t equal to 2 seconds, it's at some point x, y, z. So ये जो displacement हो रहा है from here to here, that displacement is given by this. So x minus 1 should be the x component of displacement, so it should be 30. So that means the x coordinate should become 31. Okay. Then y minus 0 is the y component of displacement, which is 40. So y should be equal to 40. And z minus 0 is the z component of displacement, which is 120. So Z coordinate should become 1, 2. So for the displacement of 30 I cap plus 40 j cap plus 120 k cap in 2 seconds, okay, from the point E, the final position at t equal to 2 seconds will be the point P, which is 31, 40, 1 in meters, because the displacement vector was in meters. Yeah, so the 14th question says that we have forces which are proportionate to sides AB, BC and twice of CA of the triangle ABC in order. Then the resultant is represented in magnitude and direction as which one? So let me explain the language of the question. What it means is that suppose we have forces F1, F2 and F3 which are proportionate to the side of triangle ABC. AB, BC and CA, all these are sides of the triangle but expressed as vectors. Then we have to find the proportionality of the resultant. The resultant of the three forces. This would be proportional to what according to the triangle. So let's understand this like this, that we have any arbitrary triangle, suppose ABC. It need not be any particular type of triangle, so it can be a scalene triangle like this, let's say. So it's saying that F1 is proportional to the side AB expressed as a vector. So that means we can represent F1 with the line AB drawn as a vector, because that's the whole idea of geometry of vectors, that you can draw arrows which are proportionate. So here the proportionality I'm assuming is the same. So this should be my F1. In that case, if I'm drawing F1 exactly overlapping AB and is proportional to AB, then F2 should be drawn exactly overlapping BC, because F2 is proportional to BC. So whatever the length of BC in meters or centimeters, F2's magnitude in newtons is some constant into that, is proportional, and its direction is the same. So if I'm showing that F1 is exactly overlapping with AB, then F2 should, because it's proportional to BC, exactly overlap with CA. But now in the same diagram, what about F3? F3 is proportional to not CA, but twice of that. F3 is proportional to double of C. So it should become the vector CA plus another vector CA. So it should be double of that. So F3 in this diagram will now look like this. F3 will not overlap exactly, but it will continue in the same direction till it goes to double of the length. So this is becoming my F3. Okay. So that is double of CA. So now what is the resultant vector in this direction? The sum of these three. The sum of these three should be the vector that you get from the origin of the first one to the head of the last one. So the sum of these three vectors should now become this. F1 plus F2 plus F3 will become this vector. So you can see that the resultant will be proportional to C, or you can see that the resultant will actually be exactly half of F3. Okay, because F1 plus F2 plus half of F3 is equal to 0, because it is forming that triangle. Because this resultant would be 0. That's why. So now we can treat this sum of the three forces as break F3 into two halves, two equal halves. So this half is becoming 0. So that's right. Okay, so that was question number 14. Let's just go over the whole concept once more. So the three forces F1, F2 and F3 are proportional to the sides AB, BC and twice of CA, where CA is the third side of the triangle, but this force is proportional to double of that. So now we have to find the resultant of the three is proportional to which of the following. So if we draw a vector diagram consisting of the forces F1, F2 and F3, assume F1 overlaps with the side AB, then F2 should exactly overlap with BC, but F3 will become double of CA. So it will overshoot CA. CA would have been just the vector from C to A, but F3 will become double of that. So that's this vector, twice of C. So the resultant of A, B and C, F3 is proportional to twice of C. So the resultant of A, B and C will now be this vector from the origin of A to the head of 3, F3. That's why it's becoming F3 divided by 2. So that is, it is proportional to CA. That is proportional to. See, this is how we are doing the vector addition. F1, then F2, then F3. But F3 is this. It's double of that. You have to join the vectors head to tail. So on joining them head to tail, you get the resultant as the vector joining the origin of the first one to the head of the last one. This becomes the result. Okay, so that's question number 15. Sorry, that's question number 14. Now moving on to 15. Okay, so let's look at question number 15. Now this is also a manipulative type of question. So it says that the magnitude of the resultant of two forces which are of magnitude 3p and 2p each is F1. So let's convert that to equations. So if F1 has a magnitude of 3p, 3 times some quantity p, and F2 has the magnitude of twice of that same quantity. So the ratio of their magnitudes is basically 3:2. And the resultant of F1 and F2, that is F1 plus F2. So the resultant has a magnitude, so that is mod of F1 plus F2 equal to R. Now the first force is doubled, the magnitude of the resultant is also doubled. So that means if we take 2F1, double of the first force, and add it to the second force, then this new resultant we get, that is this one, will have a magnitude of 2r. This is the information given to us. So understood how the question's language is converted into equations. It's given that two forces are of magnitude 3p and 2p, and their resultant is of magnitude r. Now, if the first force were to be doubled, then the resultant's magnitude would also become doubled. So this is it. If you double the first force and add it to the second, then the new resultant that we get, uska magnitude kya ho jayega? It will be double of the magnitude of f1 plus f2. That is the meaning of the question over here. Okay? Now, from this, what we have to do is we have to find the angle between the two forces. We want to find the angle between f1 and f2, let's say theta. Okay. So again, we will do this question by both methods, geometrical method as well as the component algebra method. Let's go with first, let's take method 1 as the geometrical approach over here. So suppose f1 is a vector like this, and f2 is some vector like this. This is of magnitude 3p, this is of magnitude 2p, and the angle between them is some theta. So the resultant of f1 plus f2 would be this vector now. This is f1 plus f2, and the question is giving us the magnitude of this as r. Now the second thing that is given to us, that if we double f1, so how would that vector diagram look in comparison? So let's understand how that would look. So if we double f1, this becomes double of this. So I've drawn this as 6 boxes, so that should become 12. But anyway, I'm just saying roughly. So I'm not drawing exactly to scale, but if we double f1, it is something like this now. So the direction of f1 remains the same. Direction of 2f1 is the same, but its magnitude will now become 6p, because the magnitude of f1 was 3p. So 2f1 will become 6p, and f2 has not changed. So f2 is same in direction and magnitude. So the direction of f2 should be the same as it was before. So this angle should still be theta only, and its magnitude should be 2p only, and that is the vector f2. But now the resultant of these two is this vector here. This is the resultant sum of twice of f1 or double of f1 added to f2. And the question claims that this should be equal to 2r. So this is the information given in the question converted to geometry, to two vector triangles. Now from this we have to find out theta. From this information we have to find theta. So theta कैसे निकालेंगे? By eliminating options, by eliminating variables. So from the first triangle we will get this equation that mod of f1 plus f2 is equal to r. So that means square root of f1 square plus f2 square plus 2f1 f2 cos theta is equal to r. This is the statement of the triangle law. So now substitute f1 and f2's magnitude here. So this will become 9p square plus 4p square plus 12p cos theta. 12p square cos theta should be equal to r. Now take p common. So we have 9 plus 4, that is 13, plus 12 cos theta is equal to r. Or we can just square both sides, or just leave it this way, it's fine. So this is equation 1. Now likewise, we can convert the information given in the second triangle into an equation. just like we've got an equation for the first triangle here, what we can do is we can convert the second triangle into a similar kind of equation, but similar, not exactly the same. So here, magnitude of 2f1 plus f2 is becoming equal to 2r. So that means square root of 2f1 plus square plus f2 square plus 2 times 2f1 f2 cos of the same angle theta should be equal to 2r. Okay. So 2f1 is basically 6p. So just substitute that over here. So this is becoming square root of 6p the whole square. So 36p square plus 4p square, so that will be 40 plus 2 into 6 into 2. So that will give you 24. This should be this. Or this is telling us that you take p common, you have 36 plus 4, so that's 40, and plus 2 into 6 into 2, so that's 24. Cos theta is equal to 2r. So that is becoming our second equation. Now all we have to do is solve the first and second equation. And so the first equation can be written like this, that square both the sides. So you have 13 plus 12 cos theta is equal to r square by p square, squaring both the sides and carrying over the p square that side. Similarly, the second equation, if you square both sides and take p to that side, become 40 plus 24 cos theta is equal to 4p square. 4r square by p square. Now compare these two. So you can see that 40 plus 24 cos theta will become 4 times 13 plus 12 cos theta. So this will give us a solution. So this term will be equal to this. So take the 52 to, take the 40 to that side and bring this side. So minus 24 cos theta will become 52 minus 40, so that's 12. So cos theta is minus half. So obviously that means that theta is an obtuse angle such that we use the obtuse angle formula, we will get that relation, that cos of 180 minus theta is minus cos theta. So that will become minus of minus half. Because cos theta is minus half. So 180 minus theta is cos inverse of half, which you know is 60 degrees. Therefore, theta is 180 minus 60 degrees, or theta is 120 degrees. So this is the solution of the question by the geometrical method. And this, in my opinion, is the easier method over here. We will discuss the component algebra method also, but I think this is the much easier way. So the same question can also be solved by component algebra method in the following manner. Just assume that the vectors f1 and f2 are like this. Magnitude 3p. Suppose we take this as our x-axis. Magnitude 2p and like this. So the vector f1 in our component form we will write as 3p I cap. and vector f2 we'll write as 2p cos theta I cap plus sin theta j cap. Therefore, f1 plus f2 will become equal to 3p plus 2p cos theta I cap plus 2p sin theta j cap. Okay. Now it's given to us that the magnitude of f1 plus f2 is equal to r. Okay. So therefore we can say that mod of f1 plus f2, which will be square root of 3p plus 2p cos theta the whole square plus 2p sin theta the whole square is equal to r. So when you solve this now, it will give us the same thing that we had got in equation 1 earlier, that this will become 9 plus 4, and cos square theta plus sin square theta is 1. So 9 plus 4, 13 p square plus you will get 4p square, sorry, 12p square cos theta is equal to r. So that's the equation 1, same equation we had got earlier. So all we have done in this part is we have written this vector f2 in component form. It's making an angle theta with x-axis. So f2 has been written in component form. Its x component is the magnitude, which is 2p in cos into cos, and its y component is the magnitude, which is 2p into sin theta. So the angle with respect to the x-axis is theta, whereas f1 is directly lying along the x-axis, so theta is 0 for it. So it's theta. Okay. Now the second information that is given to us, that 2f1 plus f2 should have a magnitude of 2r. So let's look at 2f1 plus f2. That will become how much? It will be 2 times f1, which was 3p I cap, plus f2, which was 2p cos theta I cap, plus 2p sin theta j cap. So double of f1 plus f2 in component form as a vector becomes 6p plus 2p cos theta I cap plus 2p sin theta j cap. Okay. So its magnitude, you have to just convert this to mod form now. So 6p plus 2p cos theta whole square plus 2p sin theta. Now this magnitude is supposed to be 2r. So now just simplify the quantity inside the square root. So you will get 36p square plus again 4p square, because sin square plus cos square is 1, and plus again 24p square cos theta, that is equal to 2r. So you can take the p common and you have square root of 40 plus 24 cos theta is equal to 2r. And this is your equation 2. Now your equation 1 and 2 are the same as we had seen in the geometrical form. So we know that solving 1 and 2, we will get cos theta equal to minus half. Which means that theta will become equal to 120 degrees. Okay, so I'll just leave you with a minute to understand the component form we way of solving it. Okay, so hope you're clear with this, people. All right, so next up, we have to move on to question number 16. Anybody has asked for it? Yeah, Ritika, okay. Fine, so let's discuss question 16. Right, so coming to question number 16, let's understand the language of the question. So it says three forces P, Q, and R are acting such that the angle between P and Q is 150 and between Q and R is 120. Then for the equilibrium of the forces, the ratio of their magnitudes has to be like this. Okay. So basically, let's say that forces P, Q, and R are acting such that the angle between P and Q is 120. There's something like this. Let's say. And the angle between Q and R is 150. So if the angle between Q and R is 150, you will see it will be like this. This angle is 150 degrees. Then automatically this angle has to become 90. Now you want the condition for P plus Q plus R to be equal to 0. So easiest is we can do this by component form. If you do this by component form, taking the direction of P as your x-axis, the direction of R as your negative y-axis, or you can even take it as your y-axis, doesn't matter. But I have taken like this. Then here in component form you can write P as some magnitude times I cap. You will have to write Q as, now the angle is 120, so cos 120 is minus half, so minus Q by 2 I cap, and sine 120 is plus sine 60 or root 3 by 2, so plus root 3 by 2 times Q. So this has been written keeping in mind that cos 120 is minus cos 60, which is minus half, and sine 120 sine 60, which is root 3 by 2. And the vector r is along the negative y-axis, so it will just be minus r. So P plus Q plus R from this is, you can see it's becoming P minus Q by 2 I cap plus root 3 Q by 2 minus R J cap, and this should be a null vector. So this is a null vector, that means each of the components is 0. So that means P minus Q by 2 should be 0, which means P should be equal to Q by 2, or that means P is to Q is 2 is to 1. And along with that, the y component should also be 0, so root 3 Q by 2 minus R should be 0, which means that root 3 Q by 2 should be equal to R, which means that Q is to R is equal to 2 is to root 3. Okay. So P by Q is equal to 2, and Q by R is equal to 2 by root 3. So from that we can find P is to Q is to R will become how much? So you can see that Q is equal to P by 2. Okay. And you can see from here R is equal to root 3 by 2 Q. That means it's equal to root 3 by 2 into half of P. Wait a second. I have to make some correction here. Okay, so we have got, oh, this is my mistake. This is P by Q. This is 1 is to 2. Okay, that's it. P is to Q is 1 is to 2, not 2 is to 1. And Q is to R is okay. This is fine. These are the two equations we have to make. So this here implies that Q is equal to 2P, and this here implies that R will become this much. Okay, so root 3 times P. So P is to Q is to R will become 1 is to 2 is to root. Yeah, if the angles are given in the other order, 150 and 120, then just interchange P to R. But importantly, the sides will be proportional to this. Okay. So this is one way of solving the question, which is making use of component algebra. If these angles are interchanged 150 and 120, they will just, this angle will still be 90, but only you will get the ratio of Q and R in reverse order. Now let's understand this question by another method. You can also solve this geometrically. P plus Q plus R is equal to 0 means that P, Q and R form a closed triangle when drawn head to tail. So this was a vector P. Now Q and R would have to be like this. Such that this angle is 120. This angle is 150 degrees. And this angle has to be 90. So basically, you can see that this has to be 60. This has to be 30. So the ratio of P, Q and R has to be such that P is to Q is cos 60, which is 1 is to. So P by Q is and again here we can use this that R is to P is perpendicular upon base. So that's tan 60. So R has to be equal to root 3 times P. So Q is twice of P and R is root 3 times P. So it will give you the same result that we got. for P is to Q is to R. So I might have interchanged the angles, in which case my answer will be different from the answer key. But you get it that the method used is the same. Just interchange 120 and 150. It will not make any difference to the method. Just the values will change. Okay, so this is the geometrical approach. Okay, so next up, let's come to question 17 then. So it says two vectors u and v are perpendicular and u is equal to half the magnitude of v. The angle between u and v in degrees is how much? The resultant of u and v is perpendicular to u, and the magnitude of the resultant is equal to half of the magnitude of v. Okay, so the angle between them is 1. So it says that the resultant of u and v, let's say r, which is u plus v, is such that r is perpendicular to u, okay, and magnitude of r is equal to half of the magnitude of v. We have to find the angle between u and v. So just draw a vector triangle, it will be very easy. Just a second. You just draw a vector triangle here. So this is the vector u. Then the vector v will have to be something like this, so that the resultant is perpendicular. And also, if the resultant has some kind of magnitude x, then this has magnitude 2x. Okay, suppose this is x. That means mod v equal to 2x. Okay. So from that we have to find out this angle, this theta. Okay. So we can use trigonometry. If this angle is some beta, we can see that beta is sine inverse x by 2x, or sine inverse half, so 30 degrees. Therefore, theta will become 120 degrees. Is this clear, people? So this is how to solve this 17th question. Okay, so next up we will do 21st question. Yes, so question 21 is that type of question where we have to look at the projection of one vector along another vector as a proper component vector notation and all that. So let's put the data of the question up first. So first of all, given to us that vectors A and B are in three-dimensional component form. E is I cap plus 2 j cap plus 2 k cap. Whereas the vector B is, just a moment, yeah. So the vector B is 2 I cap plus j cap plus 2 k cap. And we have to find the projection of vector B on vector E. We want to find on is the same thing as along. So just arbitrarily, if I were to draw the two vectors, so suppose this is the vector E. So I'm not really drawing a three-dimensional diagram like that. I'm just looking at the diagram in the plane of A and B. So if this is the vector E, and this is the vector B, and the angle between them is theta. So to find the projection of vector B on vector A, what we have to do is we have to drop a perpendicular here. Drop a perpendicular from B onto the vector E. Or just like if E was the x-axis, then the component of B along the x-axis. So like that, the component of vector B or the projection of vector B along vector E now become this way. This thing is what we are looking for. Because it's the component of B parallel to E, or the projection of B parallel to A. Let us call it B parallel. This is what we have to do. So this projection of B along E, this in my diagram is this way. You can see that this has a magnitude of B cos theta, and it has a direction which is along E, so it is E. So in other words, this is coming because the magnitude this, which we can write as E dot B divided by magnitude of, because E dot B is defined as AB cos theta. So B cos theta can be defined as A dot B divided by mod A. So going back to the two vectors that we had earlier, we can see that what is A dot B? A dot B is the dot product of B dot B is the dot product of I cap plus 2j cap plus 2k cap. Dot product with B, which was 2I cap plus j cap plus 2k cap. So that is 2 plus 2 plus 4. That is and you can see the dot product is becoming A. Whereas the magnitude of the vector E is mod of I cap plus 2j cap plus 2k cap. That is square root of 1 plus 4 plus 4. That's 3. So the component of B along A has a magnitude which will become A dot B divided by mod A, or B cos theta. The projection of vector B along A has a magnitude of B cos theta, which over here will become this vector. I mean this split by 3. That's one thing. So we got the magnitude of this. Now the direction of that projection, which we have seen earlier, the direction of it is along the vector A. So the unit vector becomes A cap. Secondly, now is along the vector E or E cap. Therefore, this is B cos theta to A cap, where A cap is basically what? The vector E divided by its own magnitude. The vector E, as we saw earlier, was 2I cap plus 2j cap plus k cap. So that divided by its own magnitude. Sorry, the vector E was I cap plus 2j cap plus 2k cap divided by its own magnitude, which we've seen as 3. So this here becomes I cap plus 2j cap plus 2k cap divided by 3. This unit vector becomes vector E divided by its own magnitude, which was 3. Now coming back here, we will substitute this for B cos theta, and we will substitute this for A cap. So our parallel component of the vector, or the parallel projection, will become B cos theta, which is 8 by 3, into the unit vector of A cap, which is I cap plus 2j cap plus 2k cap divided by its magnitude, which is 3. So next step, we can just simplify this more. So it becomes the projection of B along A becomes 8 by 9 I cap plus 2j cap plus 2. Or you can also write this as this 8 by 9 I cap plus 16 by 9 j cap plus 16 by 9. So this is the 21st question, the last question of exercise 1. So I'll just leave you with a moment to go through the question carefully. All right, so moving on to exercise 2. Question number 1 says that given the vectors E, which is 3i cap plus 4j cap, the vector B, which is I cap plus j cap, if the angle between them is theta, if the angle between them is theta, then we have to express the component of A along B and A perpendicular to B. So we have to express A parallel as A cos theta into some unit vector. So we have to find what that unit vector is. And we have to also express A perpendicular as A sine theta into some unit vector. And again, basically we have to find the numerical value of that unit vector. So we know that the magnitude of the parallel component is A cos theta. So it should be expressed as A cos theta into some unit vector. And similarly, we know that the magnitude of the perpendicular component is A sine theta. Theta is the angle between them. But what about the unit vector n cap? What should be the unit vector of this one? Okay. So let's understand the question logically, what it means first. Then we'll come back to this. Just give me a moment. Just give me a moment refreshing the whiteboard. Okay, so conceptually, what we are doing here is you can see that the vector E, which is 3i cap plus 4j cap, will be some vector like this. And the vector B, which is I cap plus j cap, will be, let's say, a vector like this. Actually, you can see that A will be the longer vector because its magnitude is 5 and B's magnitude is root 2. But just for convenience, I've written like this. So now if I drop this perpendicular here, then this becomes the component of A parallel to B. And this becomes the component of A which is perpendicular to B. So these are what are called the projections, which are perpendicular and parallel respectively. This is the parallel projection, this is the perpendicular projection. Now in this question, the options are given in such a way that we don't really want to find the projection. We just want to find the unit vectors because the magnitudes are already known. So this is E cos theta. So that should technically speaking be A dot B divided by mod B. But that's not required over here because the answer is in the form of A cos theta. And similarly, E perpendicular is E sin theta, which we know how to interpret this way that E perpendicular the magnitude is square root of A square minus A parallel square because these two are perpendicular. But here we don't want that. We want to express this in terms of A cos theta and A sin theta. But we only want to find the unit vectors. Now, as far as unit vector is concerned, we can see that the parallel component of A will be E cos theta into B cap because its direction is along B. So B cap will be vector B divided by its own mod. So that will be B was I cap plus J cap divided by its own mod is square root of 2. So B cap is becoming I cap plus J cap. Whole thing divided by. So therefore in that form we can express E parallel as E cos theta into I cap plus J cap by root. So that will give you one of the options. Okay. But we also need to find A perpendicular. So actually we need to find this in the numerical value. Now in this E cos theta should be equal to E dot B divided by mod B. So E dot B if you see will become 7. Okay, and mod B is 2. So in other words, it becomes 7 by root 2 times I cap plus J cap by root 2. Now that is 7 by 2, the whole thing into I cap plus. This becomes the numerical value. Let's just review what we've done till here. So we are finding the component of A parallel to B or along B. So that is this one. So as you can see, it has a magnitude of A cos theta, but it has a direction which is along B. So that has a magnitude of A cos theta, but the direction along B, so it's B cap. So A cos theta will be given as A dot B divided by B, so that is 7 by 2. But B cap will be vector B divided by its own magnitude, so that is this. So multiplying A cos theta with B cap, we get the numerical value of that vector. Whereas in conceptual form, it is just A cos theta into this unit vector. Now, why I needed the vector form of this numerically is because I also want to find out A perpendicular. And A perpendicular, I'll find out by that simple relationship that the parallel and perpendicular component, their sum is equal to the vector. E parallel plus E perpendicular, vector sum is equal to the vector. So in other words, the perpendicular component should become the vector E minus its parallel projection. So the vector E was 3 I cap plus 4 J cap. And just now above we have seen that the parallel component is this. This is why we needed to find this. So that we can substitute this one. This is 7 by 2 I cap plus 7 by 2 J cap. So 3 minus 7 by 2 will give you minus half. And 4 minus 7 by 2 will give you plus half. So this is becoming A perpendicular. So we can see that since we are expressing A perpendicular in the question, in the options, as A sin theta into some new unit vector, let's say M cap. Okay. So M cap becomes basically what? The unit vector of this. So it becomes minus half I cap plus half J cap divided by its own magnitude. That you will see becomes minus 1 by 2 I cap plus 1 by 2 J cap divided by square root of 1 by 4 plus 1 by 2. Square root of 1 by 2. So this will become root 2 into minus I cap plus j cap by 2. So that is minus I cap plus j cap. The whole thing divided by, this is your m cap. Finally, this is what is becoming m cap. So the perpendicular component in conceptual form becomes E sine theta multiplied by this unit minus I cap plus j cap by root 2, but which by the way numerically was equal to how much? Minus 1 by 2 I cap plus 1 by 2. But here this is the form in which we required it. So the options were giving it in this form and not in the numerical form. So this is quite a complicated business because we are doing indirect steps. First, we are finding the parallel component, and that too numerically, 7 by 2 I cap plus 7 by 2 j cap, so that we can subtract it from the original vector A to find the perpendicular component. And then from that perpendicular component expressed as a vector, which is minus half I cap plus half j cap, we have to find its unit vector so that we can express it as A sine theta into something, and that something being that unit vector. Okay, so hope this is clear to all of you. So I'll just leave you with the solution for a moment to note down and understand. Okay, now next let us look at question number 2 of exercise 2. Question 2 is somewhat simpler because we have to just check each option for its validity. Let me explain the question. So we are given two vectors A and B, and we have to check various options for whether the options are correct or not. So vector A is equal to 2 I cap plus j cap plus k cap, and vector B given to us in the question is I cap plus j cap plus k cap. Now, for example, option A is asking that the unit vector, which is perpendicular to E, is this one, minus j cap plus k cap by root. So let us check whether this option is correct. So how to check this now? So let us say this is the unit vector we are talking about. So since this unit vector should be perpendicular to E, that means two things. One is it's a unit vector, so its magnitude should be 1. So let's check mod of minus k cap plus k cap by root 2 is how much? It is square root of 1 square plus 1 square by root 2. So that's 1. So that's fine. It's a unit vector. It is a unit vector. No problem with that. But not only it should be a unit vector, but we have to check whether it is perpendicular to. So if n cap is perpendicular to E, that means n cap's dot product with E should be 0. Let's check that. So dot product of minus j cap plus k cap whole thing by root 2 with the vector e. Now, the vector e given to us in the problem was 2 I cap plus j cap plus k cap. So that's equal to how much? It is minus 1 by root 2 plus 1 by root 2. That's, so that means this is also correct. Therefore, n cap is perpendicular. So n cap is a unit vector. It is perpendicular to it. So option A becomes correct according to this analysis. Ultimately, by checking both the conditions that are asked for, that is this a unit vector? Yes, because its magnitude is 1. And is it a unit vector perpendicular to E? Yes, because its dot product with A is coming out to be 0. So option A becomes correct. Similarly, we check option B now. Option B is asking for the unit vector parallel to E. So the statement of option B is that the unit vector parallel to E is this one, 2 I cap plus j cap plus k cap whole divided by root of 6. Now this is even easier to check because now how do we check this? So we know that the unit vector along E, that is the same thing as parallel to E, is nothing but A cap, which is the vector E divided by its magnitude. So this A cap should only be this. If this statement is correct, then A cap should come out to be this vector. So let's check. So A cap is nothing but the vector A, which is 2 I cap plus j cap plus k cap divided by its own magnitude. That is mod of 2 I cap plus j cap plus k cap. So you can see that it's correct. Just do the mental calculation. You'll see the denominator is root 6 and the numerator was same. So that does in fact come out to be what was given in the option as the unit vector parallel to it. That makes option B also correct. Okay, remember, there's a multiple choice type of question, so more than one option can be correct. So this is how we are working out the second option. Okay, now we have to do likewise for option C and D also. So option C is saying that the unit vector perpendicular to D is minus j cap plus k cap by. So firstly, we can check that mod of minus j cap plus k cap by root 2 do by the same calculation will come out to be 1. So it's a unit vector. That's what we need. And secondly, if you take dot product of that unit vector, so we are calling this unit vector n cap now. So n cap dot b should be equal to 0 if n cap is perpendicular to. That is the condition we have to check. So n cap is this, and B vector was given to us as I cap plus j cap plus b. So again, you can see it is 0 minus 1 by root 2 plus 1 by root 2. That is 0. That's correct. So it is correct. So this option also becomes a correct one. This option also becomes correct. Whereas option D, you will see, is the one which is not correct, because it directly contradicts what we calculated in option B. So it says that the unit vector parallel to P is I cap plus j cap plus k cap by root. Now you can see that this is a unit vector, but it's not the correct one, because the unit vector parallel to A should be A cap. It should be vector A divided by its own magnitude, which we had seen was I cap plus or 2 I cap plus j cap plus k cap by root 3. Oh, sorry, by root 6. So this is not the correct one. This is the correct one. So option D becomes the wrong one. All other options being correct. That's question number 2 for you. So once again, I'll just scroll up so you can go through this whole thing once. Okay, so let's move on to question number 3. Okay, so question 3 is like this, that V1 plus V2 is perpendicular to V1 minus V2. So we have to interpret various options about V1 and V2. So one way is that we can understand it like this, that use dot product. That is, if E is perpendicular to B, implies that E dot B is equal to 0. Okay. So here, if you think of this as vector E and this as some other vector B, so the condition for them to be perpendicular is that their dot product should be 0. So therefore, what should happen is that V1 plus V2, its dot product with V1 minus V2 should be 0, because they are mutually perpendicular. Now open this dot product, so it will become V1 square minus V1 dot V2 plus V2 dot V1. minus V2 square. Now you know dot product is commutative, so V1 dot V2 is equal to V2 dot V1. That gives us that V1 square minus V2 square is equal to 0. So that tells us that the magnitude of V1 must be equal to the magnitude of V2. That's one thing. And see, nowhere there is a constraint on the angle between them. So the angle between V1 and V2 can be anything between 0 and 180. But this is an unnecessary solution because you already know the rhombus theorem. If you just apply the rhombus theorem, you get this directly. So we can just think geometrically. Special case of parallelogram being the rhombus theorem, that when are the diagonals of a parallelogram perpendicular? When it's actually a rhombus. So only if this side is equal to this side, whatever be the angle theta, then the diagonals of this parallelogram, which is going to reduce to a rhombus actually, will be perpendicular. That is the condition here for u plus v and u minus v be perpendicular. It could be like this. It could also be a rhombus where the angle between u and v is obtuse. It could be the special case of a square also. But the important thing is that u's magnitude has to be equal to v's magnitude. Only then the diagonals are perpendicular. The rhombus has perpendicular diagonals. That is why the options pertaining to these will be correct. That it means that it implies that mod v is equal to mod u if v plus u is perpendicular to v minus u. And the angle between u and v could be anything. So there is no restriction on the value of theta. Theta could be anything. So I've just taken the names as u and v. In the question it was v1 and v2, but essentially it means the same thing.